Hi, Jonathan, and maybe the aviation class. I have one of the airfoils up in SolidWorks here, and you can see it here. I'm going to rotate it around. This is the one you and I looked at today at lunchtime. And I just wanted to talk just a little bit about how we create this in SolidWorks and some of the things that would be helpful as we proceed. So what I'd like to do is tear this down now and show you how it was created. I'm going to, first of all, delete the triangular cut that we made there. You can see that's gone away. And now I'm going to actually delete the airfoil and leave behind just my sketch geometry. So you can kind of get a feel for how this was created. And I'm going to actually back up to my very first sketch. So the first thing I did was create two sketches, and if we look straight down at this in the top view, this is the leading edge and trailing edge of the airfoil that we looked at. It is 10 inches tall in this view and about 6 inches across down here. So that was the first step, was to get these leading and trailing edges. Next, I assume that the student wanted a perfect transition from the largest profile that was given to the smallest profile. So rather than worrying about the intermediate profiles, what I did next was create a sketch out here, and I'm going to edit that sketch real quick. And we'll look at this straight on. I created this profile sketch based upon the student data. Now, my concern is that these intermediate points, and you see everywhere you see this little star, that's a point that I put in that curve, for me was kind of pure guesswork. And I'm guessing that this leading edge is probably real critical to the performance of the airfoil. So as your students proceed with looking at these, the better I can get a sense of this curvature, the more accurate I could produce it for them. So again, going to a tinier grid paper, 1/8 inch or even 1/16 of an inch, and having them give us a good profile here, and maybe with a much thinner pen rather than maybe a Sharpie or whatever was used, would make it easier for us to try and get fairly close to their design idea. But nonetheless, you can see I plotted about 5 points for these two halves and tried to get a decent transition here. And again, I could refine that a little more, but I just wanted to test this. So that's the first curve that I created. And then I created the wingtip profile out here. You can see they're actually quite a bit separate. Let me go back straight on. And once again, from the graph paper, I made a couple of assumptions about the height and offset above and below kind of the mid-plane of the wing, and tried to get a decent curve here. You can see that it's not a real perfect transition here maybe, but in playing with these points, and you can see I can move these around, and you get a sense for what happens to that curvature as I do so. So the better the data we get, the more accurately we can try and get something that's close to what the student wants. So once I have those 4 sketches, if you will, again, the starting point, the starting profile and end profile, and then the shape of the leading edge, which for this wing was easy because it was a straight line, and the contour of the trailing edge, then we do what's called a lofted surface. So I wanted to show you how that looks. I'm going to create up here, if you can see my mouse, a lofted surface here. And I'm just going to pick this profile. And then when I pick this profile, it's going to create a straight transition from the first to the second. So you can see here, I'll zoom out just a little bit, it's created a perfectly straight transition. And here you have the simplest, I would guess, of wing shapes based on those two profiles. But we'd like it to follow this student's profile, which was not a straight line. So we'll click in this box here. This is the guide curve box. And I'll pick the leading edge, which was a straight line. And then the trailing edge curve is right here. And as soon as I click on this, it's going to reshape this wing to follow that curve. And you can see how the loft now is transitioned along that curve, along that trailing edge. Okay? I'm going to click OK, and it's now going to create for me the solid model. This is solid model geometry of that wing. Now I need to make that cut on it, so I'm going to go ahead and do that real quick so you can see it. I'm going to go to the top plane and start a sketch. And again, we'll look straight down, and I'm going to zoom up on that wingtip. And I'm going to draw a triangle right on the top of this wing. And I'm going to cheat and make that a straight line. And I'm going to dimension that triangle. And again, looking from the grid, this looked to be about 3/8 of an inch. And the student gave me a dimension here of 1/2 an inch. And then I'll just cut that. So I'm going to do an extruded cut. And we're going to say through all in both directions and hit OK. And it's going to lop that corner off the wing. We'll go back to a kind of trimetric view here. And now we can see that wing profile. I used a sharp trailing edge, again, that looked like that from the sketch, so I assume that was the desire of the student. This is a true solid model. I'll show you this. We can go to evaluate, and let's look at mass properties of this model. Now I have not assigned a material, but I can tell you that the volume of this wing is 10.873 cubic inches. And it has almost 60 inches of surface area. The purple triad you see right here, that's the center of gravity for that wing. So if I were to somehow hook that wing right there, the wing would be perfectly balanced in all directions around that point. So that's the centroid or center of gravity for the mass of this wing. You know, if we printed this solid, you could guesstimate this is actually about a $50 part to print out of solid material, just so you have reference there. Again, sparse, it's going to be considerably less, but that gives you a sense of how much material it would take to do a wing form like this at 10 inches by about 6 inches on the major axis. So that's what it looks like. Maybe that'll give your students a sense of how we can create this. The more information I can get about these profile shapes and the more detail I can get from a finer grid, the more accurately we can represent their work. If all of their wing forms are going to be just a smooth transition from the start profile to the end profile, then I really don't need any other cross sections if, like this wing, I have the shape of the trailing edge and the shape of the leading edge. So there you have it. We'll talk later, and hello to the class again. This is Mr. Randy over at Kellogg Community College, and we'll see you all soon.